So in today's lesson, we're going to be looking specifically at synthesis type reactions, and we're going to be predicting the products of those reactions. So the bell ringer for today is balancing the following equation. This is practice from last week. You should be able to do it. And if you notice, we have two elements. We have sodium here, and we have chlorine. Those reactants combine to form sodium chloride. This is a synthesis. This is a synthesis type reaction. So for the bell ringer, please balance the following equation. So let's take a couple minutes and let's predict the product here. We have hot dogs, ballpark beef franks, and we have hot dog buns. When we combine the two, what do we get? A hot dog. Here's another example. We have a bagel. We have cream cheese. When we combine the two, we end up with a bagel with cream cheese. This is a tougher one. We have a giant can of cheddar cheese sauce, and we have a bag of Mexican kitchen style tortillas. When we combine the two, we end up with nachos. So all three of those examples are synthesis type reactions. The reactants combine to make a single product. In synthesis type reactions, we have two reactants and they combine to form a single product. So this is the general form that those reactions take. When we go to do a synthesis reaction, we first figure out the charge of both reactants. So is it positive, negative? Is it positive 2, negative 3? Okay, we need to make sure we have the products of both reactants. Step 2 is to figure out the ratio of ions needed to make a neutral compound. So if we have charges that don't match up, so for example, if we had a positive 1 and a negative 2, I would need 2 cations to balance out my negative 2 anion. And then, of course, balance the reaction is our third step. So for today, we're just going to look at a couple of examples, work through these. But again, you're going to be predicting the product. So for these reactions, we have potassium and we have fluorine. Okay, potassium has a charge of positive 1. It's a group 1 cation. And we have fluorine, which has a charge of negative 1. It's a group 7 anion. Okay, so when these combine, they're going to form potassium fluoride. How do I know it's going to be potassium fluoride? We have an F2 here. We have a fluorine 2. So how do we know that this is going to be just potassium fluoride? Well, again, we want our charges to balance out. Just one fluorine gives me a charge of negative 1. So in this case, to balance this out, because we are going to have 2 fluorines here, we need a 2 here in front of our potassium fluoride. So now, if I were to do my table, let me erase this so we have some more room. If I were to do my table, on this side, I have potassium fluoride, potassium fluoride. Okay, so let me maybe backtrack a little bit. Okay, so as is, we have 2 fluorines, fluorines, we have 1 potassium. So when these combine, again, 1 fluorine gives us a charge of negative 1. So when they combine, we want these to cancel out. So I just want 1 fluorine in my product. So to balance this out, I need 2 fluorines on this side, so I have to put a 2 in front of my product. But when I do that, now I have 2 potassiums. So to balance this out, I need a 2 in front of my potassium on the reactant side. So now my equation is balanced. And again, I'm going to go ahead and put a 1 here so that I know that my fluorine is balanced. I've looked at that. All right, let's look at another example here. Okay, so let's start by figuring out the charges. So 1 oxygen gives me a charge of -2. 1 hydrogen gives me a charge of +1. Okay, so to balance this out, I'm going to need 2 hydrogens in my product, and I'm going to want 1 oxygen. So I'm going to have +1, +1, and then -2. So this gives me +2. So that's how this is canceling out. Okay. However, if I were to make my table now, when I go to balance, my third step here, I have 2 oxygens and 2 hydrogens. And on the product side, I have 2 hydrogens and 1 oxygen. So to balance this out, I'm going to need to put a 2 in front of my product. But now I have 4 hydrogens and 2 oxygens. So to make this balanced, I need to put a 2 in front of my hydrogens on the reactant side to get 4 here. And again, I'm going to go ahead and put a 1 in front of my O2. This is balanced. Okay, in this next example, we have magnesium and we have nitrogen. Magnesium has a charge of +2, and nitrogen has a charge of -3. Okay, so least common multiple here, so we have 2 and 3. So if I take 2 and I just keep multiplying it by, so by 1 it's 2, by 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and then we have 3 times 1, 3 times 2, 3 times 3, 3 times 4. And if you look here, the common multiple is 6. So when I have magnesium, 2 times 3 gave me 6. So I'm going to put a 3 after the magnesium. For nitrogen, 2 times 3 gave me 6. Oops, not 6. 2 times -3 gave me a charge of -6. So I'm balanced as far as charges on the product side. Now, if you look, let's go ahead and do our table. So we've got magnesium and nitrogen, magnesium and nitrogen. So on the reactant side, I have 1 magnesium, 2 nitrogens. On the product side, I have 3 magnesiums and 2 nitrogens. Let's try that again. 2 nitrogens. So to balance this out, I need to put a 3 in front of the magnesiums on the reactant side, and I'm just going to put a 1 in front of the nitrogens here. This is balanced. Okay, in example 4, we have aluminum and oxygen. Aluminum has a charge of +3. Oxygen has a charge of -2. And again, that's 1 aluminum and 1 oxygen. Okay, so again, I'm going to make a table here. So I have 3 and 2, and I want these charges to balance out. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So the least common multiple between these charges is 6. So this is going to be aluminum. 3 times 2 gave me 6. And then for oxygen, 2 times 3 gave me 6. Okay, so again, I'm taking the charges. So this is the charge of aluminum. 3 times 2 gave me a charge of +6. And then for oxygen, it had a charge of -2 times 3 gave me a charge of -6. So that's how I'm getting a 0 charge here, 0 net charge. All right, so let me balance this. So we've got aluminum and we have oxygen. Okay, so for aluminum, on the right side, on the product side, we have 2, and oxygens we have 3. On the reactant side, I have 1 aluminum and 2 oxygens. Okay, so to get a common multiple here, so if you look at the oxygens we have 2 on the reactant side, we have 3 on the product side. So this is kind of do the same thing that we did earlier with our table here. So these are the same numbers, 2 and 3, and we know that we want to get to 6. So on the product side, I'm going to put a 2, let me use a different color. I'm going to use a 2 in front here, and I'm going to use a 3 in front of the oxygens. Okay. So on the product side, I now have 6 oxygens. On the reactant side, I now have 6 oxygens. But when I put this 2 in front here, now I have 4 aluminums. So to get 4 aluminums on the reactant side, I'm going to put a 4 in front of my aluminum here to balance this out. Okay, so our final answer is, we write this a little cleaner, 2Al2O3. All right, we have one final example here. Iron reacts with chlorine. So in this example, you have to write out the whole thing. So we've got iron. This is reacting with chlorine, Cl2, and we don't know what that's going to give us, but let's go ahead and do our charges. So it tells us that we have iron 3, so plus 3, and chlorine. If we look up chlorine, chlorine has a charge of -1. All right, so to get this to balance, when I write out my product, it's going to be iron, and then when I do chlorine, it's going to be Cl3. The reason being, we know that we have a plus 3 on the iron. Each chlorine contributes a -1, so I need 3 of those to get my -3 to balance out. Let's do our table. Okay, on the reactant side, we have 1 iron, 2 chlorines. On the product side, we have 1 iron, 3 chlorines. Okay, so to balance this out, use a different color again. I see 2 and 3 here. Just like in the previous example, we want to get these to cancel out. So the least common multiple is 6. I'm going to multiply my entire product side by 2, and then I'm going to multiply chlorine on the reactant side with 3. So that'll get me 6. So let's see, this is going to be 6. When I multiply my iron by 2, that gives me 2 here. On the reactant side, I have 6 now, and then to get 2 irons, I'm going to put a 2 in front of my iron here. So now we are balanced. So just to write this a little cleaner, my product is FeCl3. Okay, you should have a practice worksheet. I'd like you to work on only numbers 1 through 8. The practice worksheet that you have is going to be for the next couple days when we go through the different types of reactions. So I'd like you to only work on the first 8 questions. Those are all synthesis type reactions. And when you're done, please check your answers. I will post the answer key on Google Classroom so you can check, and I'm also going to leave the practice worksheets up front for you to check during class. The exit ticket for today is to complete the synthesis reaction. This is similar to the same process that we've been doing. However, you're going to just be doing this one on your own.